Hello everyone, in this video we are doing organic chemistry, specifically condensation polymers. By the end you will see exactly how to answer questions involving condensation polymers. Like, if you are ready, subscribe for more organic chemistry videos and drop organic chemistry in the comments. Let's dive in. So before I talk about condensation polymers, I'll look at what a polymer is. So a polymer is simply a large molecule made when many small molecules called monomers join together to form a long chain. So a polymer is a large molecule made when small molecules called monomers join together to form a long chain. So the polymer is a very large molecule. And this large molecule is made by the combination of smaller molecules called monomers. And these monomers, when they combine, they form a long chain. So polymers can be found in nature or can be made by people in the industry. The ones that are found in nature are called natural polymers, while the ones that are made by people in the industry are called synthetic polymers. So natural polymers, so there are simply two types of polymers: natural polymers and synthetic polymers. So the natural polymers are polymers that occur naturally in living things or natural materials. Examples of natural polymers, we have proteins, starch, cellulose, and carbohydrates. While the other type of polymer, which is synthetic polymers, are man-made polymers such as nylon, polyethylene, polyester, etc. So they are produced by chemical reactions in factories. So these are only produced when they undergo chemical reactions in factories. So that's how synthetic polymers are produced. So there are two types of polymers: natural polymers and synthetic polymers. And there are also two types of synthetic polymers, which are addition polymers and condensation polymers. So I won't look at addition polymers in detail, but I'm looking at condensation polymers today. So I'll just talk about addition polymers just a little bit. Addition polymers are polymers formed from smaller identical saturated monomers. This simply means that addition polymers are polymers that are formed from the combination of smaller identical and saturated monomers. So what I mean by identical, I mean the same type of monomer. So for example, polyethylene is made by combining ethene plus ethene plus ethene and so on and so forth to get polyethylene. So you use the same type of monomer. So that's why additional polymers are polymers formed from smaller identical unsaturated monomers. And why am I saying unsaturated monomers? Because the monomers that I used have a double bond or a triple bond. If you remember what unsaturated compounds are, they are the hydrocarbon compounds which have a double bond or triple bond in between the carbon atoms. So ethene has a double bond in between the carbon atoms, so it is an unsaturated monomer. So when you add ethene plus ethene, which is the same type of monomer, you get polyethylene. So for addition polymers, only one product is formed, which is the polymer itself. When you add ethene plus ethene, you only get polyethylene only. And the other thing is that you use the same type of monomer. Now, the other type of synthetic polymer is condensation polymers. That's what we're looking at today. So condensation polymers are polymers that are formed by the combination of different monomers to form a large molecule with the elimination of water molecules. This simply means that the condensation polymers are polymers formed when two or more different monomers are combined, and when they are combined, a large molecule is formed with the elimination of water molecules. This simply means not only a polymer is formed, but also water is also formed. Water is also a product. A polymer and water is formed in condensation polymerization. For condensation polymers, not only a polymer is formed, but also water. But for additional polymers, it was only a polymer. But for condensation polymerization, it's a polymer and water. Addition polymers, we're using the same type of monomer, but for condensation polymers, we're using different monomers. But addition polymers, we're using the same monomer. So usually condensation polymers are formed from monomers that have two functional groups, meaning the monomers are different. they have two different functional groups. A functional group is simply a group of atoms which determines the chemical properties of a family group. For example, the two monomers. Let me give you two examples of two monomers. Dialcohol has a functional group of OH. Dicarboxylic acid has a functional group of COOH. We'll come across them as we go further. For now, they have two different functional groups. So condensation polymers are formed by monomers that have two functional groups. So they'll have two different functional groups for condensation polymers. But additional polymers, they'll have the same because they are the same monomers. So the polymer is formed together with a small molecule, which is usually water. I've already explained that. Examples of condensation polymers, we have nylon and pteridine. I'll talk about nylon and pteridine later in detail. So what is condensation polymerization? Condensation polymerization is a reaction in which monomers join to make a polymer and a small molecule such as water is formed at the same time. I already explained it. I explained that condensation polymerization is a process where two different monomers combine to form a polymer and a small molecule such as water is formed at the same time. So monomers will be combined and the polymer will be formed as well as water. There's a model, a simple model to help you understand. Monomer A plus monomer B will give you polymer plus water. So I've used two different letters because the monomers are different. You don't have the monomers that are involved are different. They are not the same for condensation polymerization. So the monomers normally have two functional groups. I've already explained that. The water molecule is removed every time a new link is formed. So every time the monomers combined, water is produced. This is why nylon and pteridine are called condensation polymers. Nylon and pteridine are called condensation polymers because when their monomers combine, water is produced. So the characteristic of condensation polymers is that water is produced at the end as well. So I'll talk about nylon now in detail. So nylon is an example of a condensation polymer, and this condensation polymer is formed by combining two monomers, which is diamine and dicarboxylic acid. Those are the monomers of nylon. The monomers of nylon are diamine and dicarboxylic acid. Diamine looks like this and dicarboxylic acid looks like that. So for us to know how nylon is formed, we first have to remove the water. Once we remove the water, then we have nylon. Then we'll combine everything to have nylon. So how is water formed? Because we know nylon is a condensation polymer, so water has to be formed. So how is this water formed? Let me show you. So the diamine will contribute hydrogen, while the dicarboxylic acid will contribute hydroxide. Again, the diamine will contribute hydrogen, while the dicarboxylic acid will contribute hydroxide. Hydrogen plus hydroxide will give you water. So that is how the water is formed. Then whatever remains is nylon. What I mean is, once you combine this part to this part, then you have nylon, and it will look like this. This is one repeating unit of nylon. When you combine whatever remains of diamine to whatever remains of dicarboxylic acid, you have one repeating unit of nylon, like this. To look like this. It will look like this. Yeah, to look like that. So nylon is sometimes referred to as a polyamide. Sometimes we refer to nylon as a polyamide. Why? Nylon is referred to as a polyamide because this is the word here. That is referred to as a polyamide because it has amide linkages. How does an amide linkage look like? It looks like this. So nylon is referred to as a polyamide because it has amide linkages. And an amide linkage looks like this. NHCO. NHCO. So NHCO is the amide linkage. Let's see if our diagram has the amide linkage. It's right here. If your diagram of nylon doesn't have an amide linkage, NHCO, then you know that you've made a mistake somewhere. So now what are the common uses of nylon? What can we use nylon for? It is used in making clothing and fabrics, making ropes and cords. Bristol, it's also used for making Bristol for brushes. So now what if you were taught to write 2 repeating units of nylon? Because this is just 1 repeating unit of nylon, this one that we have. What if you were taught to write 2 repeating units of nylon? So if you want to write another repeating unit of nylon to make them 2, you just rewrite the entire thing and put it here. So you write whatever remains for diamine plus whatever remains for dicarboxylic acid. Then you put it there. Here. You combine it here. Then you have 2 repeating units of nylon. Let me show you what I mean. As you can see, I have just repeated what I did here. Sorry. I have just written this. So you write whatever is remaining for diamine plus whatever is remaining for dicarboxylic acid, then you have 1 repeating unit. Again, if you write whatever is remaining for diamine, whatever is remaining from diamine plus whatever is remaining for dicarboxylic acid, you have 2 repeating units. So in short, once you write 1 repeating unit, just write exactly the way you wrote the first repeating unit and combine there. Again, if you want to write the third repeating unit, you write whatever you just write this exactly the way you wrote it in the beginning. Again, you write if you want to have 4. So it just depends on how many you've been told to write in exam. So that's all you need to know about nylon. That's all you need to know about nylon. Then we'll move on to another example of condensation polymerization. We'll move on to another example of condensation polymers. The other example for condensation polymers is terylene. So terylene has 2 monomers as well, just like nylon. Nylon has the monomers diamine and dicarboxylic acid, while terylene has the monomers dialcohol and dicarboxylic acid. And if you want to remember the monomers of terylene, for example, dialcohol, just ask yourself, what is the functional group of alcohols? It's OH. So di means 2. So you write OH, here, you write 2 of them. Here, again, there. In between them, you put a box. For dicarboxylic acid, again, you ask yourself, what's the functional group for carboxylic acid? It's COOH. And di means 2, so you write 2. Yeah. So that's how you remember the monomers of terylene. So now, if you want to write terylene, how do you write it? Just like nylon. Before we wrote nylon, we had to remove the water. So whatever remains after remove the water is terylene. So now how do we get the water? How do we remove the water? So this is what is going to happen. The dialcohol will contribute H, while the dicarboxylic acid will contribute hydroxide. Again, the dialcohol will contribute H, while the dicarboxylic acid will contribute hydroxide. Then whatever remains is terylene. So what you're going to do is first write whatever is remaining for the dicarboxylic acid and add whatever is remaining for the dialcohol. Then you have terylene. When you add this to this, then you have terylene. That's 1 repeating unit of terylene, and it will look like this. As you can see, the dicarboxylic acid doesn't have hydroxide, and the dialcohol doesn't have hydrogen. So you write whatever is remaining for the dicarboxylic acid and add it to whatever is remaining for the dialcohol. Then you have 1 repeating unit of terylene. So terylene is referred to as sometimes it's referred to as polyester. But if you remember, nylon was referred to as a polyamide, but pteridine is referred to as a polyester. Why is pteridine referred to as a polyester? So pteridine is referred to as a polyester because it has ester linkages. Pteridine is referred to as a polyester because it has ester linkages. So how does an ester linkage look like? It looks like this. COO, this one here. So let's see if in our diagram we have that. It's right there. So if your diagram doesn't have the ester linkage, then you know that you made a mistake. So what are the common uses of pteridine? The common uses of pteridine is that it is used in making clothing and fabrics. It's used in making clothing and fabrics. The other thing is it's used in making blended textiles. The other thing is it's used in making synthetic fibers. Now, what if in the exam you were told to write 2 repeating units of pteridine? How would you write it? You would just write the exact same thing that you've written here. Now you just put it at the end here. Whatever you've written there, you just write it. You copy this that you've written here and write it here, combine it here. Now, how would it look like to look like this? As you can see, you just write the exact same thing here that you've written here and write it there, combined. Then you have 2 repeating units of pteridine. So the point is here, if you try to memorize the structure of pteridine, you might make a mistake. But if you know the 2 monomers of pteridine and remove the water, then you know whatever is remaining is 1 repeating unit of pteridine. And if I know 1 repeating unit of pteridine, I can write 2 repeating units of pteridine. I'll just write the exact same thing for the first repeating unit of pteridine, but just combine it. Just combine the 2. And then if I was told to write 3 repeating units of pteridine, I'll put another one, 3. Again, for nylon, if you wanted to write the structure of nylon, you just write the 2 monomers of nylon, remove the water, then whatever remains, you know, is 1 repeating unit of nylon. If I want to write 2, I'll just write the exact same thing that I've written, now combine the 2. So that's how you write. But if you try to memorize, you might make a mistake. But it's up to you. If you can memorize, it's up to you. But if you understand, it will be easier to remember. So that is all for pteridine. So what is the key difference between nylon and pteridine? The key difference between nylon and pteridine is that nylon is a polyamide because it has an amide linkages, while pteridine is a polyester because it has ester linkages. So as you can see, the polyamide looks like this. The amide linkage looks like this, NHCO. Yeah, NHCO. While the ester linkage looks like this, COO. So nylon is a polyamide, pteridine is a polyester. So here are some questions I am leaving to you to answer. I seem to have written the answer. So, what is a polymer? Name the 2 broad types of polymers. Name the 2 types of synthetic polymerization studied here. What small molecules form during condensation polymerization? Why is nylon called a polyamide? Why is pteridine called a polyester? State 1 use of nylon and 1 use of pteridine. So a summary of what I just said is that a polymer is a large molecule made from monomers. Polymers may be natural or synthetic. Synthetic polymers can be addition polymers or condensation polymers. So for condensation polymers, nylon is formed from diamine and dicarboxylic acid. Pteridine is formed from dialcohol and dicarboxylic acid. Water is produced when each new linkage forms. So each time the 2 monomers of pteridine and nylon combine, water is produced. So that is all for today. Have a good day. See you in the next video and have a great day.